A single, overlooked discrepancy, not in complex algorithms, but in the most fundamental measurement of force, caused a multi-billion-dollar spacecraft to disintegrate in the Martian atmosphere, lost forever. The year was 1999. NASA's Mars Climate Orbiter, a triumph of human ingenuity, was just moments away from its crucial orbital insertion around the red planet. This sophisticated probe, costing $125 million, nearly $250 million in today's money, represented years of dedication, countless hours of brilliant engineering, and the collective hopes of a nation eager to unlock Mars's secrets. Its mission: to meticulously study the Martian atmosphere and climate, charting a course for future human exploration. Every system had been checked, every calculation verified, or so they believed. The stakes were impossibly high, with the culmination of an entire program resting on this one critical maneuver. But beneath this grand ambition, a silent, almost unbelievable error had taken root months earlier, growing like a digital weed. Two separate, highly skilled engineering teams, both critical to the orbiter's success, were speaking fundamentally different technical languages. One team, contracted by NASA, was calculating the propulsion system's performance using pound-force seconds, adhering to the antiquated imperial system still prevalent in some industries. The other team, the navigation specialists at NASA's Jet Propulsion Laboratory in California, expected those crucial thruster force calculations to be delivered in Newton seconds, the universal metric equivalent. A seemingly minor detail, an invisible unit conversion that never happened, created a chasm that would ultimately swallow the entire mission. For 9 months, the orbiter had hurtled through the vacuum of space, traveling over 400 million miles. With every tiny corrective burn from its thrusters, intended to nudge it along its precise celestial highway, the spacecraft drifted further off course. The propulsion data, received by the JPL navigators, was systematically off by a factor of 4.45, yet they continued to input new commands based on these fundamentally flawed numbers. Each new instruction, designed to correct the trajectory, only exacerbated the problem, inadvertently steering the probe onto a suicidal collision course. How was this missed? Why did no alarm bells ring? The system, designed for precision, was being fed consistent, yet consistently wrong, information, and in the overwhelming complexity of space mission control, human oversight tragically failed to spot this glaring, accumulating discrepancy. It was a ticking clock of silent, mathematical doom. Then came September 23, 1999, the moment of truth. As the Mars Climate Orbiter began its final approach, preparing to dip into the Martian atmosphere for a delicate aerobraking maneuver, a crucial step to circularize its orbit, its actual altitude was catastrophically lower than intended. Instead of the planned 140 to 150 kilometers, it plunged into the Martian atmosphere at a mere 57 kilometers above the surface. At that brutal depth, the friction, the incandescent heat, the crushing atmospheric pressure were immense, far beyond what the finely tuned, fragile spacecraft was ever designed to endure. Communications abruptly ceased. The last signals from a $250 million endeavor blinked out, swallowed by the red dust and the growing, infernal blaze. There was no recovery, no second chance, just silence. Days turned into a grueling, frantic investigation. Engineers, heartbroken but determined, meticulously sifted through every fragment of telemetry data, every line of code, every recorded calculation. The answer, when it finally, sickeningly emerged, was not a cosmic ray strike or a hardware malfunction. It was a blend of devastating simplicity and profound human error. The cause? A critical software interface, responsible for relaying propulsion data between the two teams, lacked the necessary unit conversion. It was simply a failure to translate pound force into newtons. A single, insidious oversight that cascaded through every subsequent calculation, every command, every decision, ultimately vaporizing $125 million and years of irreplaceable scientific data. It wasn't a typo in the classical sense, but a fundamental miscommunication, a failure to speak the same numerical language. The destruction of the Mars Climate Orbiter stands as a stark, chilling reminder, echoing through every modern technological project. In an age of unfathomable complexity and multi-billion-dollar endeavors, the smallest human oversight, a missed unit conversion, a forgotten specification, a silent miscommunication between teams, can lead to monumental, irreversible catastrophe. It is a profound testament to the immense power and terrifying fragility of the sophisticated systems we build. Systems where the smallest human error, the most innocuous typo, in the grand scheme, can truly bring down giants, leaving us to wonder what other tiny, invisible errors might be lurking, waiting for their moment to unravel the future. Right beneath our very noses.